So yes, energy is defined as the ability to do work, the ability to do stuff around our universe, our world, right? So the ability to do things. And energy can come in many different ways, right? There's endothermic energy, which we talked about is specifically related to chemical energy, and this is when chemical energy gets absorbed or enters into a chemical reaction. Remember, the way to remember this is that endo looks a lot like the word enters. Exothermic energy is then the opposite. The word exo looks a lot like the word exits. So this is when chemical energy is released or exits a chemical reaction. Potential energy, we said potential energy is like the potential you have to fall, right? So this is the energy stored by an object's position, all right, which we will be learning more about today. And then kinetic energy, we know that the word kinetic means motion. So that's automatically what you should think of. You should think of it as the energy due to motion. Smiley faces emojis in the chat if you feel comfortable with this review from yesterday. We're going to be continuing to expand on this review today. Thank you, Mallory, in the chat. Thank you, Itati. Amazing. Smileys emojis, everyone, if you feel comfortable with this review, since we will be expanding on it today. Let me know in the chat. Thank you, Angelina, Jayland. Excellent. All right, let's go ahead and go over some announcements. Again, don't forget to have your notes open. That way you can also get attendance during this time, notes and attendance. Here we go.
All right. So good morning, everyone. So as always, please do not share any personal information during class. Your participation is required as always, and that these Connect sessions are always recorded for learning purposes. Let's see what we're getting into. So today is Tuesday. We're getting more into Unit 3. We're going to be learning about potential and kinetic energy. All right, which is kind of like the beginnings of our entire unit, which everything in this unit is going to be about energy and work and machines and how that all functions. All right, specifically, this will entail defining the conservation of energy. We will provide examples of how energy can be transformed and explain how kinetic energy and potential energy are related. All right, kind of connecting to yesterday's lesson. All right, hopefully we should be pretty solid on this by the end of the lesson. Let's go ahead and raise our hands for the notes. The links are still at the bottom of the chat if you need them. If neither of them work, of course, a foolproof way is to always just access it through your.
All right. Yeah, Seraphim looks like having some tech issues, getting logged out a bunch, so hopefully everything's okay. All right, what I want to know in the room chat today, what is the scariest part of a roller coaster? Go ahead and tell me in the chat, what do you think is the scariest part of a roller coaster? I have a terrifying picture of a roller coaster up here. I don't know if this is a real picture. This seems really alarming. Excellent. I see Shada. I see Angelina in the chat. What is the scariest part of the roller coaster? Let's get some more participation. Seraphim in the chat. Jonathan, Mallory, not scared at all. Jalen, Benjamin, let me know in the chat. Thank you, Itati. Yes. Okay. So I would definitely agree. I think most people think the scariest part of a roller coaster is going to be right as you're waiting at the top of the drop. Right? Waiting at the top of the drop. Absolutely. And so it's definitely scary because you're just completely still and you are as high up as you possibly could be, and you're like facing down, and you're like, oh my goodness, what's going to happen? So I agree. I think that's probably the scariest part of a roller coaster as well. Next question, where do you think you're moving the fastest on a roller coaster? Are you moving the fastest at a roller coaster at the top while you're waiting, and the middle as you start to go down, or at the bottom? Where are you moving the fastest on a roller coaster? Go ahead and tell me in the chat. Jonathan, Angelina, you're saying the middle. Go ahead and participate in the chat. Where do you think you're moving the fastest? Okay, so this is actually a common misconception. A lot of people will say that you think you're moving the fastest at the middle, but you're actually gaining speed as you go further and further down the hill. So that means, where are you actually going the fastest? As you move down the hill, think about, you start off really slow and then you start to gain speed. Where are you actually going the fastest? Yeah, at the bottom of the hill. Absolutely, at the bottom of the hill. Think about it in this way. If you are out of control on a skateboard or on roller skates or on a bike, right, you would much rather crash near the top of the hill or near the middle of the hill, then go all the way to the bottom and crash at the bottom of the hill. It's going to hurt a lot more because by the time you hit the bottom of your hill, you have gained so much speed that it's going to be really painful. So you're actually going the fastest at the bottom of a roller coaster. Now, again, where are we moving the slowest then? We kind of already touched on this, but where are we moving the slowest on a roller coaster? So moving the fastest, I think, is probably the funnest part. Again, where's the scariest part? Where are you moving the slowest? Just connecting this back up to what we were talking about. Yeah, exactly. So yes, I see Angelina in the chat. Kaden, jump back over to the room chat. You're in the Q&A chat right now, so no one else can see your answers. Yeah, so we are moving the slowest at the top of the roller coaster, which again, I think probably contributes to why this is a little bit scarier because you're just waiting there, waiting, waiting, waiting. You're moving very slow. You're at rest for a moment, just waiting for the drop. Okay, so again, just to review, I think most people say at the top is the scariest. You're actually moving fastest at the bottom, not the middle, a common misconception because again, your speed picks up the further down you go. And again, at the top, you are completely motionless for a moment right before that drop. All right, so this is going to be related to potential and kinetic energy today. So let's go ahead and jump into talking about energy some more.
All right, so learning about conservation of energy. I believe I accidentally mentioned this early during our last lesson, but the conservation of energy is simply the statement that energy cannot be created or destroyed, but it can be transformed from one form to another and transferred from one place to another. So, for example, in a saw, electrical energy is transferred into light energy, kinetic energy, and thermal energy. So, at any point during a like mechanical action or with a machine or an energy source, we will see this take place in multiple different scenarios in everyday life. With the saw, it's mainly using electricity to do work, but most of that work is not going into cutting whatever it's cutting. Some energy is being wasted in the form of light from those sparks that you see. The kinetic energy is what's actually cutting like the pipe or whatever it is, and then the thermal energy is being given off because the metal or the material is heating up as the saw cuts whatever it is cutting. All right. Yeah, it is transformed and it is transferred. All right, so for number 2, go ahead and type in the word transformed and raise your hand when you are ready to move on. I will give us 20 seconds.
Excellent. All right, so let's go ahead and actually try this out. We talked about these different types of energy yesterday. So let's go ahead and look at these different scenarios. So we have fuel is used to move a rocket. So the starting energy is coming from our fuel. So take a look here. What kind of energy is fuel? The main ones that we talked about yesterday is we talked about heat energy, we talked about light energy, potential energy, sound, electrical, chemical, and kinetic. So go ahead and tell me in the chat, what is fuel, a type of energy? What type of energy is fuel? Go ahead and tell me in the chat. Think about fuel is what? If you have a bucket of fuel, this is a what? Go ahead and tell me in the chat. Thank you, Jonathan. Yes, exactly. So fuel is a chemical. So this is definitely starting out as a chemical type of energy. Now then, right, we're able to combust or burn that fuel, and that fuel begins to move the rocket. So we're ending up with the rocket moving. What type of energy is that? Think about moving or motion. What type of energy is it when we are moving or in motion? Make sure you're participating. Make sure you're learning this because you will need to do this on your own in just a few slides. So if we begin to move, what energy is related to movement slash motion? Go ahead and tell me in the chat. I see Jonathan with an answer. Let's get some more participation. Thank you, Cody. Thank you, Angelina. Let's get Kamal, Timothy, Alicia, Mallory. Thank you, Shayna. Let's get Carlos in the chat. Benjamin, Jayland. Thank you, Jaime. Excellent. There we go. Yes, exactly, Kai. Exactly, Mallory. Matthew. Perfect. This is going to be kinetic energy. Absolutely. we are going from chemical energy to kinetic energy. Again, we can see that this energy is being transformed. It's being changed. There's some stuff that goes on in the middle too, right? You can see some heat and some light, right? But again, mainly we're starting off with our chemical fuel, ending up with motion, kinetic energy. Now let's go ahead and try a different example. So your body digests food and uses it to move your muscles. So again, we're starting off with digesting food. Tell me in the chat, food is what type of energy? Is it heat energy, light energy, potential, sound, electrical, chemical, or kinetic? What kind of energy is food? Excellent. I see Cody coming in with it. Yes, exactly. Food is just like fuel. So this is absolutely a chemical type of energy. That's what we're starting with. And similarly, if we are moving our muscles, then this type of ending energy is what? Again, thinking about movement, if we are able to use that food, burn it in our bodies to make our muscles move. To make our muscles move, what's that going to be? Thank you, Jonathan. Let's get Chantel in the chat. Let's get Kalina in the chat. Seraphim, Matthew, Joseph H. Again, this idea of movement. We just talked about this with our rocket, so this should be very familiar. Thank you, Kalina. Let's get Noah in the chat. Let's go. More participation, please. Movement, movement. Thank you, Kamal. Yes, exactly. This is going to, again, be kinetic energy. So you'll notice here that both of these scenarios are examples of going from chemical energy to kinetic energy because we're starting off with chemicals, fuel, or food, and we're ending with motion, either moving a rocket or moving our muscles. That is both kinetic energy. Go ahead, give me a green check, orange checks if that's beginning to make sense. Again, connecting what we learned about the different types of energy yesterday to this idea of conservation where energy can be transformed, it can be changed. Excellent. Let's go ahead and take a look at our next example. All right, so this time, let's imagine we have gravity pulling water downhill. All right, so let's go ahead. Sorry, give me one moment. I just want to make sure that I put the right thing that I want you to get out of this. Okay, perfect. Okay, so we have gravity pulling water downhill in a dam, and then the dam is then able to produce electricity. It has generators or turbines that can then use that moving water in order to produce electricity. So let's go ahead and take a look at this one. So we have gravity pulling water downhill, so that water is moving, right? So that water is moving. Tell me in the chat, movement is what type of energy? Movement is what type of energy? We have water moving, falling. Yes, exactly. So one more time, we have this idea of kinetic energy. You'll notice there's a lot of motion, kinetic energy. And this time, though, it's producing electricity. What type of energy is electricity? Take a look at its name. That should be pretty self-explanatory. What type of energy is electricity? Thank you, Jonathan. Thank you, Shayna. Let's get everyone in the chat. This one's an easy one to make sure we're participating and reinforcing our own learning on. Thank you, Angelina. Alan, go ahead and tell me in the chat what type of energy is electricity. Chantel, thank you, Kai, thank you. Jaime, Noah, Cody, Itati, excellent. Yeah, this is going to be electrical energy, right? So electricity is just electrical energy. Amazing. Let's take a look at our next one. Solar cells capture sunlight to produce electricity. So take a look here. If we're starting off with sunlight, what type of energy is that? Is that is that heat, light, potential, sound, electrical, chemical, or kinetic? Thank you, Jonathan. Thank you, Shayna. I see Cody working. Thank you, Lena. Thank you, Angelina. Yeah, exactly. So we start off with sunlight. That's going to be our light energy. This, just so you know, can also be called radiant energy. So just like heat is often called thermal energy, light is often called radiant energy. Like you're radiant, you're glowing like light, okay? Now the ending energy again is this time we are producing electricity again. So electricity is what type of energy? Electricity again is what type of energy? We already took a look at a different way to generate electricity up here. Right? You can generate electricity with water or you can generate it with solar cells. Yeah, electricity is definitely going to be electrical energy. All right, so you've learned how to kind of figure this out. You've learned some different scenarios of conservation of energy, how energy is transformed. Let's make sure that you really understand this with our next application problem.
All right, so here we have a complete on your own for number 3 in our notes. We have a bunch of terms, definitions that we need to match up. So let me just reference these for a little bit to know what we're getting into. We have chemical to kinetic, light to electrical, and kinetic to electrical. So all of these three terms are basically like a type of transfer of energy. And then for the definitions, we have a rocket uses fuel to blast off, a dam uses falling water to make electricity, solar cells use the sun to make electricity, and food is used by the body to move muscles. So we need to connect the correct transfer of energy with the correct description of what's happening in real life. All right. I will give us about a minute to do this. So if any of you need help, you will be in the Q&A chat, but please do not post any answers in the room chat. And when you're done, please make sure you raise your hands. All right, so learning about potential and kinetic energy. So potential energy is the stored energy an object has due to its position or height. So the most common example we have of this, right, is with the roller coaster, right? We start high up on a roller coaster, we have a lot of potential energy and zero kinetic energy if we're stationary, and we go down and all that potential turns into kinetic. All right, but when the object is released, it begins to move and potential energy is converted to kinetic energy. So another example of this, however, is that waterfall example that we have where it's a dam forcing the water through a specific opening that's using the water as being at a higher position on one side and transferring it to a lower depth on the other side. And that kinetic energy is what drives turbines, which then can be used to be stored as probably electrical energy, if I were to guess. All right. Uh, let's see. So let's answer some things in the chat here. So the dam example continued. Water is held high above the ground. All right, what type of energy is this right here for the first blank? Answer in the chat. All right, you can type answers in the chat. I give you guys permission. Type some answers in the chat. What type of energy I just explained is when the water is held high above the ground. All right, so a lot of height is what type of energy, right? Look at the green text. Angelina, I'm going to assume that that's a little typo at the end there, but that's all right. Potential, exactly. So this is potential energy. So when the water is released in the following scenario, when the water is released and gravity makes it fall downwards, what type of energy is it now turning into? All right, think of the roller coaster. You're high up, you got potential energy, you're going down. What type of energy is it transformed into? All right, awesome, Noah. Anyone else? Joseph, very good. Couple more maybe. Angelina, perfect. And Cody, awesome. So yeah, this is going to be kinetic energy. Kinetic energy. Then the dam uses the motion of water to turn turbines and to create electricity, which is what type of energy? It's kind of self-explanatory. What type of energy is electricity? This is very easy. You just gotta change the word a little bit. Yeah, good, Angelina. Can I get a couple more in there? A couple more answers in the chat. Awesome. Yeah, it's going to be electrical. Remember from last lesson, electrical energy, all electrical energy is the movement of electrons. All right. So we have our transfer from potential to kinetic and finally electrical. All right. Pretty awesome, guys. Let's move on. So for number 4, in your notes, let's write the word stored for number 4.
All right, here we go. You should be able to see this up on the whiteboard here. All right, so I'm going to go ahead and make sure that you can see the speed of our skater here. I'm going to make sure that you can see the energy of our skater, and we are on the L graph. I'm going to also do it in slow motion. All right, so let's go ahead. I'm going to drop the skater up here and just let them do what they do. Again, I could do it normally, right? So show you the normal speed. And now let's go ahead and see it in slow motion. right? And you can see that something's going on with the energy here, something's going on with the speed here. So let's go ahead and begin to analyze what's happening at each point. So when our skater is up at the top of the hill, all right, their speed, is it slow or fast? Go ahead and tell me in the chat. Their speed, is it slow or fast? Again, I can restart it just so that everyone can see it. So right here, their speed, is it slow or fast? Look at the speedometer. Look at the speedometer right here. Literally says it's the lowest it could possibly be. Yeah, so yeah, right here, this skater is at rest. So they start at rest at the top of the hill, much like in a roller coaster, you start at rest at the top of the hill. So you're slow for the moment, you are completely motionless before you start falling. And so if you're at the highest point, you can see here that we have all of what type of energy? Tell me in the chat, we have all of what type of energy? Take a look at what you see here. Showing that this is all currently what? Kinetic or potential energy? Yes, this is all potential energy because, again, they're at the highest point they could possibly be. That means they're at the highest potential to fall, and they're not moving. So they have no kinetic energy yet because they're not moving. Smiley faces emojis in the chat if that makes sense. You're at zero speed. You're at the highest point. That means you must have all potential energy. All potential energy. Cool. Now let's go ahead and go a little bit further. And see, now they're in the middle of the hill. So what's happened to our speed? What has happened to the speed? Has it stayed the same at 0? Has it increased, decreased? Yeah, we've gotten a little bit faster here, absolutely. And taking a look here, we can see now we're moving a little bit, so we have some kinetic energy. But we're not as high as we once were. So you'll notice the potential energy, did it increase or decrease? Now that we've kind of lost some height, did our potential energy increase or decrease? Remember, it started all the way up here. So what happened to our potential energy? Yeah, it decreased. So that should make sense. Our height is lower, and so we have less potential to fall. So we have decreased potential to fall, but we are increasing our kinetic energy as we begin to move faster. Now let's go ahead and take a look what happens once we get to the bottom of our ramp. All right, so now we're at the bottom of our ramp, and again, what has happened to our speed? Again, what has happened to our speed? Has it gotten slower, faster, or stayed the same? Yes, there we go. I see Angelina in the chat. Let's get some more participation. Thank you, Kaden. Again, before it was around here. At the start, it was at 0. So what's happened to our speed this time? Yes, we've gotten even faster. All right, this is actually the fastest that the skater is going to go. And can they fall any further? Yes or no? Can they go down any further? Do they have any more height left? Yes or no? Do they have any potential to fall further? No. So what you can see here is they no longer have no potential energy. They have no height, so they can't go any further down, right? No more potential to fall, but they are moving the fastest speed possible, so now they do have a lot of kinetic energy. Now, what I want you to notice is this entire time, what is happening to the total energy? So I'm going to go ahead and replay this, and I want you to pay attention to the yellow bar. This entire time, what happens to the total energy? Does it increase, decrease, or stay the same? Tell me in the chat, looking at the yellow bar here, total energy, does it increase, decrease, or stay the same? Excellent, I see Angelina working. Again, we only have 5 minutes left and I still have several slides to get through. We need to be participating. What's happening to our total energy? Yeah, it's actually staying the same. So even though we can see that our potential energy is changing into our kinetic energy, in total, the total amount is still the same. And that goes back to this idea of conservation of energy, where we can't delete or add energy to our universe. The total amount will continue to be the same. Please go ahead and give me a green check, orange X if that makes sense. Again, at the top, we had lots of potential. At the bottom, we had lots of kinetic, where we're moving the fastest. But in total, the total stayed the same the entire time. Excellent. All right, let's go ahead and jump back to our PowerPoint here and talk a little bit about this. Okay, so going back to our roller coaster example, again, potential and kinetic energy can actually exist at the same exact time. We saw this. So at the top of our roller coaster, though, again, where we're at the highest height and not moving, what type of energy is that? When we are at the highest height and not moving, what type of energy is that? Is that going to be potential energy or kinetic energy? When you're at the top of the hill, all the way up here. If you're not moving, so think about, you can't have the type of energy related to moving. So highest height. Thank you, Cody. Thank you, Angelina. Thank you, Joseph. Yeah, if you are at the highest possible height possible, that's going to mean that you have a lot of potential energy. Also, if you're not moving, you have zero kinetic energy. So we have 0% of this energy is kinetic, and 100% of your total energy is potential. Okay, smiley faces, emojis in the chat if that makes sense. All right, so we have 100% potential energy at the top. Great, excellent. Now, once we get to the middle of our roller coaster, so now we are at like a medium height, and we're also at a medium speed. So tell me, what types of energy do I have here? Only potential, only kinetic, or both? If I still have some height, now I also have some speed. Is it only potential energy, only kinetic, or both? Thank you, Joseph H. Thank you, Kaden. Thank you, Angelina. Yeah, exactly. This is going to be both types of energy. So I'm just going to put this as 50-50. Obviously, this can change a little bit depending on where you are in the middle. But for our purposes, just imagine it as 50-50. It's half of each. Now at the bottom of our roller coaster, again, we no longer have any height, right? So we have no height. And we're moving at our fastest, right? We're moving at the fastest speed possible. So what type of energy is this? All potential, all kinetic, or both? If we have no height left, but we're moving at our fastest possible speed, is that all potential, all kinetic, or both? Thank you, Noah, Angelina, Kaden. Let's get some more answers. Seraphim, Alan, Chantel, Kai, Lena, Kalina, Shayna, Jaime, Itati, Noah. Oh, sorry, I already got Noah. Callie. Thank you, Lena. Thank you, Jaime. Yeah, exactly. So if we're moving at our fastest possible speed, but we no longer have any potential to fall, that means we have zero potential energy, and all of our total energy is now 100% kinetic. Okay, so again, you need to keep in mind that the higher you are, the more potential energy you have, and kinetic energy means you have more velocity, you're faster. So this actually is related to being lower, right? So the higher you are, the more potential energy you have, and the lower you are, the faster you are, and therefore the more kinetic energy that you have. All right, so this is going to be the answer to number 5. Go ahead and match these up. And this is also the answer to number 6. Go ahead and fill in those blanks. You have 45 seconds. Please work quickly. We still have some more to get through. All right, so our last question here. Thank you, Kai. Our last question here is, where is the most potential energy, therefore the least kinetic energy? So this means that potential energy related to height, we need to think about where are we having the most height, the most potential energy. All right, the second part of number 7 is then matching where's the most kinetic energy, right? So think about where are we going to have the least potential energy, the least height, and the most kinetic energy, the most speed. All right, so you have some options here. A at 100 meters high, B, which is at 0 meters, it's on the ground, C, which is at 35 meters, D, which is a little bit above the ground, or E, which is at 20 meters. Go ahead and answer question number 7 and then raise your hands. This is a complete on your own. If you want to check your answers, we're in the Q&A area. You have 30 seconds to go ahead and raise your hands. Go, 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 because we are out of time.
We provide examples of how energy can be transformed and explain how kinetic energy and potential energy are related. So let's just go straight to our last slide here. If you haven't already, go ahead and submit your notes for the day. All right, and if you do not need to go back and look at anything else, or if you don't need any assistance, go ahead and exit the course. Have a great day, and we will see you guys tomorrow.